Okay, problem 14, find the product. Okay, so the way you want to approach these is you actually are going to first look at these signs. When there's nothing, it is a positive here. This is a positive. So your first question should always be, what is this times this? So what is a positive times a negative? So positive times negative is a negative. You can already eliminate answers at that point because you know that your answer needs to have a negative. So C and D are not good answers. So all you got to remember now is, what is 3 times 8? 24. Now if you forgot, all you need to do is say 8 plus 8 plus 8. Take it slow. What is 8 plus 8? That one's 16. What is 16 plus 8? 24. So this is a negative 24 if you have 3 negative 8s that you are adding together. Remember, this means 3 groups of 8. So 3 groups of negative 8. Find the product. Now you're just multiplying 3 at a time. So take it slow. First multiply the 3, positive 3 times a negative 5. What is that? Positive 3 times negative 5 is a negative 15. Notice I didn't multiply it all. Now I just write the negative 2. So negative 15 times negative 2. So that's how I got that part. Now let's color code this. And we are going to multiply what's negative 15 times negative 2. A negative times a negative is a positive. So before I even finish, I can already mark off the negative answers because I'm going to be done after this. So 15 times 2 is going to be a 30. So 30 is your correct answer. Evaluate this expression. So you have 18 minus 3x when x equals negative 2. Remember how we do table groups in the class? X is the lowest number, right? So it represents something here. All you need to do is take this negative 2, plug it in everywhere you see x. So I like to always say, oh, I see an x, put parentheses. Now what do I put in the parentheses? Well, I'm going to put whatever x is equal to. So I'm going to put that right here. So we're going to take this and put a negative 2 inside the parentheses. Now, what is a negative 3 times negative 2? We're doing that first based on PEMDAS. So that's why I didn't do the, if you do 18 minus 3 first, you would get the 15 times negative 2, then you would get negative 30. That would be the wrong answer because you didn't follow PEMDAS. So let's erase this. So following PEMDAS, there are parentheses, but nothing inside the parentheses to simplify. Nothing to do with exponents. Multiplication, yep. Negative times negative is a positive. 3 times 2 is 6. Keep it in parentheses. What is positive 6 times 18? So positive 6 times 18. So what is that? Oh, my bad. I don't know why I'm saying positive 6 times 18. So you have positive 6 here. What's 18 plus 6, right? Because this beginning operation here is subtraction. So we don't change it to multiplication. So I think when I put the parentheses, that's why I just read it like that. 18 plus 6 is going to be 24. Same thing here. You are going to plug in. It would help if this was all on one line. So going straight across, I'm going to rewrite it. 3x minus 5y. So you're going to put 3, parentheses, whatever the x is, minus 5, parentheses, whatever the y is. So let's color code things. X is equal to 9. The x was right here. Y is equal to negative 7. The y is right here. So plug in x, which is 9, right? Plug in the negative 7 here. PEMDAS at this point. Parentheses, yes, but there's nothing to do in them. Exponents, nothing to do. They're all on ones. Multiplication, yes. So we're going to multiply first. What's 3 times 9? 27. Minus, what's negative 5 times negative 7, actually? Positive 35. What is 27 plus 35? So we're done with multiplication, division. We're on addition. 62. Okay, describe the commutative property of addition and the associative property of addition. Simplify the expression 4x plus 8 plus negative 6x. Explain how the commutative and associative properties were used to simplify the expression. Okay, so commutative property, let's review. Commutative is something like 3 plus 4 or 4 plus 3, they both give me 7, right? Or, likewise, if you did 3 times 4 or 4 times 3, just flipping it, it still gives you 12. Now, associative is similar, but it has 3 terms. So you have the grouping is what changes things, or it keeps it the same, actually. So let's erase this so I have some room. Now, associative would be something like if I did 3, 2, and 5, right? And I say, okay, 3 times 2 times 5 is the same as if I did, hold on, let me change the notation. 3 times 2 times 5 is equal to 3 times 2 and then times 5. Or if I did 3 plus 2 plus 5, this is the same as 3 plus 2 plus 5. So basically the order that I added in together, it doesn't change. So this one would be 5 times 2 is 10, 10 times 3 is 30. 3 times 2 is 6, 6 times 5 is 30. 2 plus 5 is 7, 7 plus 3 is 10. 3 plus 2 is 5, 5 plus 5 is 10. So on this one I got 10 on both. On this one I got, 30 on both. So now let's look at the expression 4x plus 8 plus negative 6x now that we refreshed our memory on that. How is it that the commutative and associative properties were used to simplify this expression? So if I do something like, actually I can move this. Let me move this real quick below, so we still have those notes. Okay, now I have room for it. So I'm going to write 4x plus 8 plus negative 6x, all right? I can write this as negative 6x plus 4x plus 8, and I would still get the same answer. This is an example of the commutative. I just switched it around. Now for associative, let's put it in a different color. Associative would actually be something like, let's see, 4x plus 8 was the original plus negative 6x. So I would write 4x plus 8 plus negative 6x, right? And I would look at this and say, oh, if I combine, and I combine this one first, let's say I do this one first, and then add this would be my associative property here. So the plus is on the outside, this is on the inside. Okay. So make sure you understand these, and then try to understand this. The reason why you may have understood this, but this one seemed harder to you, was because this one deals with the variables, but you can't get tripped up on just the fact that it has variables. I want you to notice that it still has 3 terms. So on this one, this had 1, 2, 3. Okay, so this still had 3 terms. This one had 1, 2, 3. So both had 3 terms. It's just a matter of thinking of it as only terms. You have to split it apart. So this had more parentheses going on in brackets too, but that's just because of the negative, because of the organization. All right, let's go to 19 and 20. These are the last 2 problems, so let's do these. An expression is shown below, 3 times x plus 2y plus 4z. Draw a model or diagram to represent this expression. Use your model or diagram to expand the expression. So here, they want you to do the distributive property model. So you would have 3 on this side. Then you'd have a area here. So you're doing the area model. So this would become x. This would be plus, bringing this down, 2y plus 4z. Let's just save this for now. Okay. Plus y plus 4z. So I just wrote this one on top, this one here. And notice the pluses are because of where, or this line is because of where the pluses are. So when we were doing this on a worksheet, it would actually look like this, the worksheet we did in class. They broke it up on all 3. So I just glued them together by adding that plus. So you would have x here, 2y here, 4z here. That's how your worksheet had it. Then you would answer what's 3 times x? 3x. What's 3 times 2y? 6y. What's 3 times 4z? 12z. 12z. So here this would be 3x, 6y, 12z. Completely the same, just have it to where it's glued together. Now we have 3x plus 6y plus 12z is how you want to write out the final answer. So this would be your final answer here. So this is using a model. This is called an area model, this picture right here, or a diagram. Really, this area model is the only way we represented it in class. We could do algebra tiles and break it up like that, but we focused more on this. So I'm expecting to see area model, but if you have another way and it works, it's fine. You can put that on there. Okay, so that one's answered. Write an equivalent expression for 4x plus 12. So this is still using the area model here. You have to just remember that it actually goes on the inside. So we did a worksheet like this in class, and you are factoring this out. So what do 4 and 12 have in common? So you could take this slow and say 2, 2, this one was 4, 3, 2, 2, 3. So if I do 2 times 2 times 3, I get 12. If I do 2 times 2, I get 4. If you line them up like this from least to greatest, then you would see that you have these in common. So you have 2 and 2. 2 times 2 is 4. That means 4 can go into 4, 4 can go into 12. So you do this if it doesn't come naturally, if you don't feel so strong on multiplication tables. So now we can take out a 4. 4 times what gives me 4x? Well, it would be a 1 and an x. 4 times what gives me 12? 3. So now we need to write this as 4 times x plus 3. So we found one way to rewrite this. So an equivalent expression, we rewrote it this way. Now there's other ways we could write it as well. Actually, almost infinite many ways, because it doesn't say you have to factor it on this, it just says write it in an equivalent way, and we learned about combining like terms. So combining like terms. So this one was factoring. Here, this is factoring. But combining like terms, we could actually break up that 4x and say, hey, 2x plus 2x, that would equal 4x, plus 3 plus 4 is 7, plus 5. Is that the same as 4x plus 12? Yeah, you could do this infinite many ways, because now if I add it together, yeah, I got 4x. 3, 4, 5, yep, get 12. So I still get 4x plus 12. So this could be another answer as well. As many ways as you want for combined like terms, because I could even add negatives and go back and forth on it. So I could add to this problem right here, and I could say plus 2x, but then minus the 2x, and this is still 4x plus 12. So could just keep on going with combined like terms. There's no ending to it. Okay, that's everything.